All right. So we're going to take care of 9(5), which is about the dot product. So the dot product is something that we do with vectors when we're multiplying them together. So when we multiply two vectors together, we use the dot product. Now the dot product is interesting. The dot product actually does not give you a vector when it is done. It gives you a constant. You'll see the word scalar quite often when talking about vectors, not a vector. We have something else to do with vectors to kind of put them together in a multiplication type way. But the dot product is just, it's going to give us a number when we're done, not a vector. So how you do the dot product of two vectors is you're going to multiply the I components and the j components. So the two numbers that are attached to the i's, you multiply those. You take the two numbers that are attached to the j's, you multiply those, and then you're going to add them. So here's our formula right there in our box. So let's take a look at some examples. We have our vector 3i minus 4j, our w vector 5i plus 2j, and we're going to find our dot product of v dot w. So we're going to take our two I components, 3 and 5. We're going to multiply those. We're going to take our two j components, -4 and 2. We're going to multiply those. We're going to add everything. So we get 15 plus -8, which is 7. So that's the dot product for that first one. When we reverse the order and do w dot v, taking our dot product, you'll see that we take our 5, we multiply it by our 3, we take our 2, multiply it by our -4. It's the same thing. You can reverse the order of the two vectors and you get the same product there. If you do v dot v, so we're going to take our v vector, which is 3, multiply it by the other I component, which is the same thing, and add our j components. Sorry about that typo, I didn't notice that, which is -4. So we're going to do -4 times -4. So that's 9 plus 16, which is 25. So dot product, pretty straightforward, has some useful qualities. Taking a look down here, I remember looking at this first time and thinking, what the heck is going on here? So when we have two vectors, we can find the angle between them. So think about like a vector here and a vector there. And what if you want to know the angle between them? We have this formula. You'll notice that our angle is going to be between 0 and pi. That has to deal with the inverse cosine's output. So we're going to take cosine of the angle between the two vectors is the dot product. So the dot product is on top. So that's just a value, not a vector, excuse me. And then we have our magnitudes on bottom. And we multiply those two numbers. So those would be two values. We're going to multiply them. We take our dot product, divide by that number. Cosine of our angle will equal that thing. So let's see this in action. We have our vector for 3. So I'll sketch that. There's our vector v. And then our vector w is 6, -4. It's going to be down here. And we want to find the angle in between them. How are we going to do that? We're going to use our formula. So cosine of the angle between them is going to equal. On top, we're going to do our dot product. So we're going to take the I components, 4 times 6. We're going to add that to the j components, 3 times -4. On the bottom, we need our magnitudes. And then we're going to multiply those. So actually, let's do some work over here on the side. The magnitude of v. If you didn't watch the 9-4 video, you won't know how to do this. It's gonna kind of look like the distance formula. We're gonna do 4 squared plus 3 squared. We're gonna take the square root of that. That'll be 5. The magnitude of W, we're gonna take the square root of 6 squared plus negative 4 squared. That's gonna be what? 36 plus 16. Which is 52, square root of 52, which I don't think we need to write simplified, but I'll do it anyways, 2 square root of 13. So coming back to our actual work, cosine theta equals on top here, 24 minus 12. So we got 12 on top. On the bottom, we're going to have 5 times 2 root 13. Or if I guess we simplify it just one more step, not absolutely needed. Cosine of the angle between the two vectors is going to be equal to 12 over 10 square root 13. Now, this is not a unit circle thing. So we have to use inverse cosine here. So if you take the inverse cosine of that ugly looking fraction, we get about, if we're in degrees, so I was in degrees when I did this, we normally do a lot of degree stuff with vectors. Oop, you can barely see that, about 70.6 degrees. So this is kind of challenging to do. It's kind of a little funky getting used to this at the beginning, but if you got that formula sitting in front of you, we're thinking dot product and magnitudes. So we got one more page to go, short section, but a lot of examples here to do on this page. Okay, when the angle between vectors is 0 or 180, this means that there's a non-zero scalar c such that the vectors are equal. Another way of putting that is when you look at these vectors, they're going in the same direction, or if they're not going in the same direction, they kind of can lie on top each other and go exactly opposite each other. And that should make sense. If the angle between two vectors is 0, they're going in the same direction. If it's 180, they're just kind of going in opposite directions. So we're going to find the angle between the vectors v and w given v is 3i minus 7j and w is negative 6i plus 14j. Verify that the vectors are parallel. How these vectors going to be parallel? They're going to have an angle between them of 0 or 180. So if you want to try to do this on your own for a second, use that formula from the previous page. Press pause, see if you can do this. I'm going to get my work started soon. So cosine of theta, we have to take the dot product. So we're going to do 3 times negative 6 plus negative 7 times 14 on top. And then we need the magnitudes on bottom. So the magnitude of v, the magnitude of w. So again, here I'm going to do a little side work. Magnitude of v is going to be the square root of 3 squared plus negative 7 squared. 49 plus 9, that's the square root of 58. If it simplifies, it doesn't matter. I'm just going to leave it. Magnitude of w is going to be negative 6 squared plus 14 squared. We're going to add those, take a square root. 196 and 36. That is going to be 232. That probably simplifies, but yeah, you could take a 4 out of that, but don't care. So we're going to take our little formula here. Cosine of theta is going to equal here on top, negative 18 plus negative 98 over square root of 58 times the square root of 232. And this actually simplifies quite nicely, everybody. We get negative 116 on top. We get 116 on bottom. So we now have cosine of theta equals negative 1. That is something we can do without a calculator. But if you'd like to use inverse cosine, if you are in degrees, it's going to give you 180 degrees. And that 180 degrees is going to tell us that our vectors are parallel. Next kind of special vectors we have are orthogonal vectors. You'll see here, orthogonal is going to mean perpendicular. I don't know Where orthogonal comes from, I just know when, I took more math classes, through school and stuff, I started using the word orthogonal quite a bit. And then we use orthogonal very much around vectors. We don't say perpendicular all that often. These vectors are going to meet at right angles. And what's interesting for us is that if the dot product is 0, you know that the vectors are orthogonal. So you don't even have to do this whole thing if you don't want, but I'll show you what happens when you do this whole little formula thing above to verify that the vectors make a 90-degree angle with each other. So we have two new vectors, V and W. So let's jump into the dot product. If I do V dot W, we get -3 times 4 plus 2 times 6. It's -12 plus 12. That's equal to 0. If the dot product is 0, you know they are orthogonal. But what if you didn't remember that? That would be okay if you could come up with that formula. Cosine theta equals our dot product on top. We just found it was 0 on bottom. I got to do some more magnitudes. -3 squared plus 2 squared be square root of 13 for the magnitude of V. Magnitude of W, that would be 4 squared plus 6 squared, take square root of that. So 16 plus 36 is 52. So we get the square root of 52. And after all that, it doesn't even really matter much anyway, because 0 divided by whatever is 0. So we get cosine of the angle equals 0. And if you were to take inverse cosine of both sides, the inverse cosine of 0 is 90 degrees if you are in degrees, which would tell us that the two vectors are orthogonal. For our last example, we're just going to do this one more time. We're going to find the dot product. We're going to find the angle between them, and then we're going to state whether the vectors are parallel, orthogonal, or neither. So again, at this point, you probably can do all of this on your own if you want to try and then check your answers. Otherwise, you can watch me walk through it. So part A, looking at our vectors I plus square root of 3j and I minus j. So if we do V dot W, that's going to be 1 times 1 plus square root of 3 times -1, which is 1 minus the square root of 3. I'm just going to leave it like that. So that's our dot product. Part B wants the angle between. So I'm going to be smart this time and find magnitudes first. Magnitude of V. So we're going to take the square root of 1 squared plus the square root of 3 squared, which is the square root of 1 plus 3, which is the square root of 4, which is 2. Magnitude of W. Square root of 1 squared plus -1 squared, square root of 1 plus 1, which is the square root of 2. So the angle between these two vectors, cosine of that angle will be the dot product, 1 minus the square root of 3, over on bottom 2 times the square root of 2. Now, you simplify this, you actually might see some numbers that we recognize. If you wanted to know what I mean by simplify, I would multiply top and bottom by the square root of 2. You're most certainly welcome to leave it like that. But if you multiply this top and bottom by the square root of 2, we get square root of 2 minus square root of 6 over 4. You might remember this number from a chapter ago. Maybe you'll see when we get the angle what I'm kind of talking about. But anyways, if you were to do the inverse cosine of 1 minus the square root of 3 all divided by 2 square root of 2, your calculator is going to spit out at you that the angle is 105 degrees. Now this is not parallel because it's not 180. It's not orthogonal because it's not 90. So we're going to say that these vectors are neither parallel nor orthogonal. On Friday, we're going to talk about vectors in 3 dimensions. Doesn't get much harder than this. I know that this is already quite enough, but it's good to know that this is kind of maxing out here at our difficulty level.